In this lab, we will use spectroscopy to determine the concentration of an unknown solution. Before we do that, we need to set up several dilutions of a known concentration. So we're going to take this solution of blue number 1. This is a 1.24 molar solution, and we're going to fill it about 10 milliliters full in test tube number 1. So we're going to call this test tube number 1, and it contains our concentrated 1.24 molar solution. Then we're going to transfer 5 milliliters of this stock solution into a graduated cylinder, and then add water to the 10 milliliter mark. This will be our first dilution. So we need to make sure we're as precise as possible with this, so we have good dilution measurements. So I added 5 milliliters of my concentrated stock solution to the graduated cylinder, and then 5 milliliters of water. This is my first dilution, and I put it in test tube number 2. Then what I'm going to do is I'm going to take 5 milliliters out of test tube number 2 and put it in the graduated cylinder. And then I'm going to add water to that graduated cylinder to dilute it again. These are 1 to 2 dilutions. I'm going to keep doing this until I have 10 test tubes of solution. Spectroscopy is a way of measuring the amount of light a solution sample absorbs. A beam of light with a known wavelength is passed through a sample. In our lab, we are going to use a red beam of light with a wavelength of 635 nanometers. When we shine the beam of light through our solution, a detector on the other side of the solution measures how much light actually passed through versus being absorbed. The more concentrated the solution, the more light it will absorb. The more dilute the solution, the less light it will absorb. So now that I'm done with my last solution, I've put some paper behind these solutions so you can see how they progressively get less and less and less concentrated. The last thing I'm going to do here as I set this up is put my unknown concentration in a test tube. I'm going to fill a test tube about half full of my unknown concentration. And I want you to just eyeball it and see which of these dilutions matches that unknown the most. So in front of me now I have 12 cuvettes. Cuvettes are the way that we will be getting these samples into our spectrophotometer. The first cuvette, I'm going to add distilled water. This is going to be my blank cuvette, kind of like how you hit 0 or tare on a balance. This is how we will zero out the spectrometer. Now I'm going to fill a cuvette with my unknown solution. Then I'm going to fill the remaining 10 cuvettes with each of the remaining solutions in order so I can keep track of them, make sure I don't get them mixed up. Now we're going to move to the spectrophotometer. On the spectrophotometer, set the wavelength to 635 nanometers and make sure that it is measuring absorption. 635 nanometers represents red light. Alright, the first thing we're going to do is set our blank. So wipe any fingerprints or debris off of the blank cuvette, insert it into the machine, close the lid, and hit the 0 button. This is similar to hitting the 0 or tare button on a balance. What we're doing is we're telling the machine to disregard the absorbance of the cuvette itself and the water in the solution. Next, we're going to insert each cuvette one at a time and record the absorbance reading. By measuring the respective absorbance values for solutions with known concentrations, a calibration curve can be constructed. The absorbance of an unknown can be calculated through the use of your calibration curve.